Now let us clarify some terminologies related to learning. The first thing is, what is training or a learning process? The training or learning process is basically adjusting the weights and bias of the different feature variable of a hypothesis starting from random so that it can predict the output variable properly. What does that mean? That means, let's say you have a table, something like this, and here is an input variable called x1, and then there is an input variable called x2, and let's say the output variable is y, and then there are lots of data set over here. So there are many different rows and something like this. So these are your variables. Now let's say you want to fit a model something like this. Let's say y equals theta 0 plus theta 1 x1 plus, let's say, theta 2 x2, like this way. So what does that mean? So now these theta 1, theta 2, these are called weights related to these inputs x1 and x2. Or sometimes it is basically nothing but a coefficient of the equation. X1 and x2 are basically the input variables, whereas theta 1, theta 2 are their coefficient. Alternatively, we call them weights. That's it. And the other thing is this theta 0, that is another terminology, or sometimes we call it a bias also, because it does not have anything in this model. So in machine learning, you basically start these theta 0, theta 1 and theta 2 from some random number, let's say like 0, 25, then 33, or some any type of number, let's say between 0.001 or something, any type of number you can start with. Now in the training process, when iterating over this entire data set, you have to adjust these coefficient. Well, these 0, 25, 33 were just some random guess just to start with, but eventually analyze the data, and then you have to configure, change or readjust all these coefficients or these weights and biases, and that's the learning process. So learning process is nothing but start these weights and biases from random places and then readjust it based on the data, based on analysis of the data. That's training or learning. Now, what is testing? Testing is basically an evaluation process of your trained hypothesis or trained model with unknown dataset. But that data should follow the similar probability distribution of the training dataset. So normally in a machine learning, what we do in an entire dataset, let's say in this entire table, we take 80% of the data for training purpose, and then in the same data set we utilize 20% data for testing purpose. So since we are selecting from the same data set randomly from here and there, it is very likely that the probability distribution of the training set and the testing part will be similar. So that's the common practice. Now, in order to easily visualize, you can take this situation as testing. For example, let's say instead of x1 and x2, let's say you have the household income of uh, every room in every house of a city, And not only that, and also you have the age of the owner of that house. So this is your x1 and x2, and you are trying to predict the real estate price. Let's say this is a real estate price that you want to predict. Now let's say you have the data set for, let's say, some New York City. You have the data set, everything from the New York City, and you got all the data set over here. Now when you, let's say you have trained the model on top of this New York City data, and then here you have got like 80% of data is training data set, and 20% of the data you have used for testing purpose. But eventually it is all New York City data, right? It's all from the similar geographic or demographic region. Whenever, so this is basically the testing. Whatever we are doing, we are confining ourselves in New York City data only. That's testing. Whereas when you evaluate the trained model with entirely unknown data, that process is called validation. For example, now instead of only testing with the New York City data, now, or instead of evaluating your trained model on only New York City data, you got the data from the entire United States. So you got the entire United States data, which includes the data from San Francisco, which include the data from Ohio, and many other different states. So those are entirely different data set. So whenever you will evaluate the trained model with this data set, that is called validation. So you got some data of New York City, you trained on that New York City data, that is training. Then you tested on the same New York City data itself, that is testing. But after you got the model from New York City data, if you check or evaluate with entire United States data, that is called validation. Now the next terminology is accuracy. Accuracy is basically a measure of how good a model is. It is basically a number that represents correctly predicted data points out of all the data points. So you can get like 50% of data is predicted correctly, or 90% of the data is predicted correctly, or 99% data are predicted correctly, something like that. On the other hand, loss is just the opposite. It is a number that indicates how bad the model prediction is on a single example. So there are many different functions which you can use for loss function, or sometimes we call them an error function, because this is basically telling you the amount of errors that are in your model. One of the very popular model is mean square error function. In mean square error, and this is the mathematical formula where you are basically taking the square of the difference of the actual data and the predicted output, and then you are taking their square, and after that you are just adding all of them and taking the average after adding. So that's mean square error. So square of the difference of the actual value and the predicted value, and the mean of that entire thing. That's the mean square error. Now, when it comes to these learning related terminologies, one thing is very important to know, which is called overfitting. And overfitting is when a model exactly fits the training data, that is, it shows very high accuracy and almost zero loss, that is no error when testing against the same training data set. But it starts showing a very bad result, or the loss is very high whenever it is tested on some entirely different validation data set. So it is exactly same as the real world situation. Let's say during your exam time, you are reading your textbook. You read one textbook, let's say textbook A, for so many times that you remember each line of that textbook. So instead of learning the fundamental concept written inside that textbook A, you just read the textbook A so many times that you can remember each of the different lines of the textbook, but you missed the fundamental concept. Now, in the exam, what happened? Instead of asking the question from textbook A, the instructor gave some other question which was not in textbook A. So what will happen? You will perform bad in the exam because it is not from textbook A. And then in the second question is directly coming from the textbook A line. And you, of course, perform better in textbook A, right? So that's called the overfitting. And similarly, there is something called underfitting, when a model is not trained for enough time, or sometimes it may happen that some important feature or input feature or feature variables are ignored during the training. So at that point of time, underfitting can happen. But rather than underfitting, overfitting is a major problem in machine learning model. Normally, the software developer tries to use a lot of different columns and attributes and try to make some very complicated model which works with the training data set, but eventually that complex model fails on the validation dataset. Just like the fact, if you just quote everything from your memory from textbook A, you will perform worse in an exam where there are several questions from outside the textbook.